Welcome back to Signal 2030. Today, we're diving into a molecule many of you probably think you know pretty well, creatine.
Yeah, it's been around forever in the sports world, right?
Exactly. A cornerstone for athletes for decades.
Yeah.
But the latest science, it's revealing some really surprising stuff way beyond just the gym.
Totally.
If you thought creatine was just for, bodybuilders packing on muscle, well, get ready for a bit of an update. The research coming out, say, 2023 through 2025 is painting a much richer picture.
It really is.
We're talking potential impacts on brain health, maybe healthy aging, even mental well-being. It's kind of wild.
What's really fascinating to me is watching how our understanding has shifted. It's not just about lifting heavier weights anymore.
Right.
We're now looking at its role in fundamental cellular energy, resilience, and all these, well, what scientists call pleiotropic effects.
Pleiotropic,
Meaning it does multiple different things in the body. It's not just a one-trick pony.
Okay, multiple actions. So what does this actually mean for you listening right now? Well, that's what we're going to unpack today.
Yeah, let's dig into the science, bust some myths.
Oh, definitely bust some myths and see how this, honestly, seemingly simple compound might be shaping our future health. Get ready for some aha moments, I think.
Hopefully.
Okay, so for those of us maybe only familiar with the muscle side of things, let's do a quick refresher, the basics. How does creatine actually work inside our cells?
Good place to start. So at its core, creatine is a naturally occurring amino acid compound. Its main job. It revolves around the phosphocreatine system, PCR for short.
PCR. Got it.
Think of it like a super fast energy reserve, especially in tissues that need energy now, like muscles and, importantly, the brain.
Like a quick charge battery.
Exactly like that. Its job is to quickly regenerate ATP adenosine triphosphate.
Right, ATP, the universal energy currency. We learned that in biology class.
That's the one. Your body needs roughly 2 to 4 grams a day. You make some yourself, mostly in the liver and kidneys, and you get some from food, red meat, seafood, that kind of thing.
Okay.
And get this, about 95% of it, it's stored right in your skeletal muscles.
95%. Wow.
Yeah. So when your cell needs that immediate burst of power, PCR hands over a phosphate group to ADP, that's adenosine diphosphate, and boom, you've got ATP again. Almost instantly.
So that's for those first few seconds of intense effort, like a sprint or a heavy lift.
Precisely. The first, say, 6 to 8 seconds, it bridges the gap before the slower energy systems can really ramp up.
Okay, so it really is like that fast-charging battery. And when people supplement, usually with creatine monohydrate, that boosts these internal stores by, what, 20 to 40%?
Yeah, that's about right. A significant bump. And that's, of course, where the performance benefits come in, but also where some of the, maybe the confusion started too.
And the myths we mentioned.
Definitely. But beyond just that primary energy role, we're seeing really strong evidence for those pleiotropic effects I mentioned earlier.
Like what else?
Well, one thing is cell volumization. When creatine goes into muscle cells, it draws water in with it.
Ah, okay, so that explains the initial weight gain people sometimes report. That 1 to 3 kilos.
That's it, exactly. But it might not just be a side effect. Some researchers think this swelling itself acts as an anabolic signal, like it tells the muscle, hey, time to grow, maybe stimulating protein synthesis.
Interesting, so not just water weight.
Potentially not just water weight. And beyond that, it seems to influence how cells handle calcium. It helps muscles store more glycogen, that's your stored carb energy. It can reduce protein breakdown, and maybe even act as an antioxidant and anti-inflammatory.
Wow. Okay, so it's doing a lot more behind the scenes than just providing quick energy.
It really seems to be a very versatile molecule.
Now, this is where things get really, really interesting for me and probably for a lot of listeners. Creatine isn't just for muscles anymore. The brain that's emerging as a huge area. What are we learning there?
Oh, absolutely. The brain is, it's an energy monster. Only about 2% of your body weight, but it guzzles maybe 20% of your daily energy.
20%.
Yep. And it relies heavily on that same PCR system for quick energy. So recent studies, particularly meta-analyses from the last couple of years, 2023, 2024, 2025, they're showing pretty consistent improvement.
Improvements in what exactly?
Things like short-term memory, attention, focus, even how fast you process information. One big meta-analysis in 2024 found a standardized mean difference, or SMD, of 0.31 for memory, which is statistically quite significant.
Okay, a measurable boost for memory.
Yeah, and here's a really crucial point. These cognitive benefits, they seem to be most noticeable when your brain is under stress.
What kind of stress?
Think being seriously sleep deprived, or intense mental fatigue, or even low oxygen conditions that's called hypoxia.
Right.
There was a study in 2024, really fascinating. It showed that even a single high dose of creatine, we're talking about 0.35 grams per kilo of body weight, could actually counteract the cognitive slump you get after being awake for 21 hours straight.
Whoa, okay. That changes things. Because I always thought you needed to load it for weeks to get any brain benefits.
Right. That's what we used to think. This suggests it might be more dynamic, maybe even have acute effects on brain resilience. Now, it is worth mentioning, for significant brain benefits, you might need higher daily doses than for muscle. Maybe 10, even 20 grams a day?
Why so much higher?
It's mainly about getting it across the blood-brain barrier. It's a bit of a hurdle, so you need more circulating to push enough through.
Makes sense. Okay, so helping the brain stay sharp under pressure, that resilience idea, could that connect to, say, mental health?
That's a really important question, and yes, the link is being explored. We know many psychiatric conditions often involve problems with brain energy metabolism.
Okay.
And there was a compelling pilot trial just published in 2025. It was a randomized controlled trial looking at depression. They found that adding creatine monohydrate to standard CBT, that's cognitive behavioral therapy.
Right, CBT, common talk therapy.
Exactly. Adding creatine led to significantly greater symptom reduction compared to CBT alone. And this fits with some earlier work suggesting it can also boost the effectiveness of SSRIs, the antidepressant medications.
SSRIs like Prozac or Zoloft. Okay, so potential synergy there.
Potential, yes.
Yeah.
But, and this is important, it's not a magic bullet for everything. For bipolar disorder, for instance, the evidence is more cautionary. There are some concerns it might potentially trigger manic episodes in susceptible individuals.
Okay, so definitely needs careful consideration depending on the condition. Nuance is key.
Absolutely. Very important nuance.
Now, you touched on metabolic stuff earlier.
Yeah.
And there used to be some, let's say, confusion around creatine and blood sugar, maybe diabetes.
Yeah.
What's the latest thinking there?
You're right, there was confusion.
Yeah.
But a really landmark study in 2024 in Science Translational Medicine basically flipped the old ideas on their head.
Flipped them how?
They found that people with type 2 diabetes actually have lower levels of a specific enzyme in their muscles. It's called mitochondrial creatine kinase 2, or CKMT2.
CKMT2.
And this lower level impairs how their bodies use creatine properly. It means creatine doesn't get metabolized efficiently in the muscle, so it sort of backs up and accumulates in the bloodstream.
So wait, the high blood creatine isn't causing the diabetes?
Exactly. It seems to be a consequence or maybe a biomarker indicating that the creatine energy system within the muscle isn't working right in people with type 2 diabetes.
Wow, that's a huge shift.
Mm-hmm.
It connects faulty energy metabolism directly to the condition.
It does. It provides this really novel link, a potential aha moment for diabetes research, for sure.
Definitely. So beyond muscle, brain, mental health, diabetes, any other clinical areas showing promise?
Oh, for sure. We're seeing really good results in managing sarcopenia. That's the muscle loss that happens as we age. Especially with resistance training, creatine helps preserve muscle, improve strength and function.
Makes sense, given its muscle energy role.
Right. And it can also help maintain bone mineral density alongside that training. Plus, there are benefits seen in certain types of muscular dystrophy, like Duchenne muscular dystrophy.
Okay, but not a cure-all, you mentioned.
Definitely not. It's important to be clear. It has been found ineffective for slowing down diseases like ALS, amyotrophic lateral sclerosis, or Huntington's disease. So it works for some things, not others.
Got it. And any really cutting-edge research, new frontiers?
Yeah, some exciting areas are emerging. Things like recovery from TBI, traumatic brain injury. Especially in kids, there's actually an ongoing trial looking at concussion recovery and also tackling that persistent, debilitating fatigue some people experience with long COVID. Still early days, but promising lines of inquiry.
Okay, wow. So the potential applications are really broadening out, which brings us, inevitably, to safety. Because despite all this, myths persist. Let's talk safety.
Yes, let's. And honestly, the safety profile of creatine monohydrate is one of the most studied things in the entire supplement world. There was a huge systematic analysis in 2025 looked at 685 clinical trials.
685.
Yep. Over 12,000 people who used creatine. And the conclusion, no statistically significant difference in reported side effects between the creatine groups and the placebo groups. Adverse events are exceptionally rare in healthy folks.
Okay, that's pretty robust data. So let's hit the big one. Does it wreck your kidneys or your liver?
Ah, the kidney myth. It just keeps going. It comes from a misunderstanding. Supplementing does increase a waste product called creatinine in your blood.
Right, and doctors measure creatinine to check kidney function.
Exactly. They use serum creatinine levels to estimate something called eGFR, your glomerular filtration rate. But in this case, the higher creatinine is just a harmless result of turning over more creatine. It's not a sign of kidney damage. Countless studies show no harm to healthy kidneys or liver function.
Okay, so it's an artifact of the measurement, not actual damage.
Precisely. Now, obviously, if someone already has kidney disease, caution is advised, like with many things. But for healthy kidneys, not an issue.
Good to clarify. What about the hair loss thing? That one is all over the internet.
Oh, yeah. Another classic myth, mostly debunked now. It all traces back to one small study from 2009.
Just one.
One small study. It reported an increase in DHT, that's dihydrotestosterone, which is linked to male pattern baldness. But crucially, that study didn't actually measure hair loss itself. The sample size was tiny, and its finding about DHT hasn't been replicated in bigger, better studies.
So later studies didn't find the same thing.
Correct. In fact, a solid randomized controlled trial in 2024 directly measured hair counts, hair density, testosterone, and DHT levels. After 12 weeks of creatine supplementation, no effect. No change in hair loss, no change in hormones.
Okay, so the hair loss connection looks pretty weak based on current evidence.
Very weak, yes. Seems to be largely unfounded fear based on misinterpreting that one old study.
Right. And quickly, what about those old claims of dehydration or cramping? Still hear those sometimes.
Yeah, and the science actually points the other way. We mentioned creatine pulls water into cells, right? That intercellular water retention.
Yeah, the cell volumization.
Well, that seems to actually help with thermal regulation and managing body heat, and might even reduce the risk of dehydration and heat illness during exercise. And the cramping claims, just not backed up by research, no consistent link found.
Amazing how these myths stick around. So it seems incredibly safe for most people. If someone wants to try it, based on all these potential benefits, how should they actually take it? What's the best way?
Okay, practicalities. The most researched, most effective, and usually the cheapest form is plain old creatine monohydrate. CRM, that's the gold standard.
Creatine monohydrate.
Yep. You might see micronized monohydrate. That just means the powder is finer, so it dissolves a bit easier. It doesn't change the effect, just mixability.
Okay. And how much? Do you need that loading phase that people talk about?
The loading phase is optional. It just gets your muscles saturated faster. If you do it, it's typically 20 grams a day, split into maybe 4-5-gram doses for about 5 to 7 days. Or you can calculate it as 0.3 grams per kilogram of your body weight per day.
And if you skip loading?
If you skip loading or after the loading phase, you just take a daily maintenance dose. Usually 3 to 5 grams a day is enough for most people.
3 to 5 grams. Okay.
If you're a larger athlete, maybe you need a bit more, say 5 to 10 grams. But honestly, consistency is way more important than hitting an exact dose or stressing about timing. Just take it every day.
Does it matter if you take it with food? I've heard carbs help.
Taking it with carbs or protein can slightly boost uptake because of the insulin spike they cause, but it's not essential. The difference is pretty small. Consistency matters most.
Okay, stick with monohydrate, 3 to 5 grams, daily maintenance. Consistency is key. What about all those other fancy, often more expensive types, like creatine ethyl ester or liquid creatine?
Ah, yes, the marketing hype versus the science. This is important. Most of those alternative forms, they just don't stack up. Creatine ethyl ester, CE, for example, has actually been shown to be less effective than monohydrate because it breaks down more easily in your stomach into an inactive byproduct.
So less effective and more expensive.
Pretty much. Liquid creatine is also notoriously unstable. It degrades quickly in water. Forms like creatine hydrochloride, HCl, or buffered versions, they simply lack solid independent evidence showing they're superior to monohydrate. Often they just claim better solubility or less bloating, but the performance data isn't there.
So the takeaway is, don't waste your money. Stick with the proven stuff.
That would be my advice, yes. Stick with good old creatine monohydrate. It works, it's safe, it's affordable.
Good to know. Now, we've talked benefits across the board, but research hasn't always been great at including everyone. Women's health, for instance, often gets overlooked. What's the story with creatine for women specifically?
Yeah, that's a really crucial point, and frankly, a big gap we're still trying to fill properly. Women's physiology around creatine is different. Some research suggests women naturally have lower stores to begin with, lower endogenous stores.
Endogenous, meaning naturally produced in the body.
Exactly. And their creatine metabolism seems to fluctuate with hormones like estrogen and progesterone. So the picture is more complex.
So does it work as well for women?
The evidence is a bit mixed, honestly. Some early reviews suggested yes, it helps with strength in premenopausal women, but a big systematic review in 2025 found many studies actually showed no significant improvement in active women.
Why the discrepancy?
A lot of it might come down to poor study design in the past. Many studies just didn't control for the menstrual cycle phase, which, given the hormonal influence, is a pretty big oversight.
Ah, okay. That makes sense.
But here's a really interesting finding: the cognitive benefits. The brain boosts we talked about, especially for memory. A 2024 meta-analysis suggested those effects might actually be stronger in women.
Stronger in women. That's fascinating.
It is, and potentially really relevant, given that women experience higher rates of depression and anxiety, conditions linked to brain energy. Also, for postmenopausal women, higher doses, maybe that 0.3 grams per kilo per day, combined with resistance training, looks really promising for preserving both muscle mass and bone density.
Okay, so still more research needed, especially well-controlled studies, but some really promising signals for women's health, both brain and body.
Definitely an active and important area of research.
What about other groups, say older adults or people on plant-based diets?
For older adults, creatine is looking fantastic, really helpful for fighting off sarcopenia, that age-related muscle loss. Combined with resistance training, it significantly improves muscle strength, power, and just general physical function, helps people stay independent longer.
And cognitive benefits for older adults, too.
Yes, absolutely. Studies show memory improvements there as well, likely because brain energy levels naturally tend to decline with age, and creatine helps shore that up.
Makes sense. And vegetarians or vegans?
For vegetarians and especially vegans, the benefits can be even more dramatic. Because they get very little creatine from their diet, their baseline muscle stores are usually much lower than meat eaters.
So supplementation makes a bigger difference for them.
Potentially, yes. They often see greater improvements in both physical performance and, interestingly, cognitive function when they supplement. And the good news for them is that almost all creatine monohydrate on the market is synthetically produced, not derived from animals, so it's generally vegan-friendly.
Good point. Okay, finally, let's tackle the really contentious one. Creatine for teenagers, for adolescents.
Yeah.
Science versus policy. It seems like a real clash.
It really is a complex and, contentious area. If you look purely at the scientific studies that have been done in young athletes, and there aren't a huge number, but they exist, they generally show positive results.
Okay, as in?
Improved performance in high-intensity sports, things like sprinting, jumping, and importantly, a pretty good safety profile in those short-term studies. Some data even hints at lower injury rates in teens using creatine, and we know higher dietary intake is linked to healthier growth.
Okay, so the science seems tentatively positive.
Right. But the official policies from major groups like the American Academy of Pediatrics, AAP, generally recommend against creatine use for anyone under 18.
Why the caution then?
Their main argument is a lack of extensive long-term safety data, specifically in adolescents. They want to see more research tracking effects over many years before giving it a green light. And this caution is amplified by how supplements are regulated under DSHEA, the Dietary Supplement Health and Education Act.
How does DSHEA play into it?
DSHEA puts the focus on post-market surveillance. The FDA doesn't pre-approve supplements for safety and effectiveness like they do drugs, so pediatric groups tend to be extra cautious. This has even led to states like New York passing laws just in 2024 restricting the sale of creatine and other muscle-building supplements to minors.
Wow, state laws restricting access.
Yeah. And the challenge is this official caution clashes with reality. We know lots of teens are using creatine, often getting info from TikTok or Instagram, not necessarily reliable sources.
Right.
And scientific bodies like the International Society of Sports Nutrition, ISSN, they push back a bit. They argue that creatine is safe based on available evidence and that restricting access might just push young athletes towards trying riskier, unproven, or even dangerous alternatives.
So it's a real dilemma. Caution versus potential harm reduction and practical reality.
Exactly. It's a tough balancing act with no easy answers right now. Needs more dialogue and definitely more adolescent-specific long-term research.
Looking ahead then, towards 2030 maybe, what's the overall market for creatine looking like? And how is this regulatory picture likely to keep evolving?
Well, the market's definitely booming, no question about that. You see these huge growth projections. Now, the actual dollar figures, they vary wildly depending on who's counting, and how I've seen estimates for 2025 ranging from like zero point 0.2 billion USD all the way up to 2.7 billion.
That's a massive range.
It is, reflects different methodologies, but the trend is clear. Massive growth. It's driven by wider health awareness, all this new science we've been talking about moving beyond just muscle. And let's be honest, social media plays a huge role too.
And what are consumers looking for? Any specific trends?
Powder is still king, but capsules are growing fast, mainly for convenience. People want transparency, they want clean labels, and they're increasingly looking for third-party certifications. Things like NSF Certified for Sport or Informed Choice.
What do those certifications mean?
They basically verify that the product contains what the label says it contains, and importantly, that it's been tested for banned substances, which is crucial for competitive athletes. Purity and safety assurance.
Okay. And that regulatory environment sounds like it's still very much in flux, that tug of war you mentioned.
Very much so. Federally in the U.S., it's still under DSHEA, so the FDA mostly reacts after a problem arises, post-market surveillance. But states are getting much more active. New York's 2024 law restricting sales to minors was a big deal, and other states are watching or following suit.
Creating a patchwork of rules.
It's exactly a fragmented market, which is a headache for companies, and it leads to pushback from industry groups like the Council for Responsible Nutrition, CRN, and also from scientific groups who feel some of these laws are based on outdated fears or misinformation about creatine safety.
So ongoing debate there. Given all this activity, what are the really big questions researchers are focused on right now? What's next on the research agenda?
Oh, it's a super active field. We're seeing major ongoing trials looking at concussion recovery. That TBI research is really important. Also for long COVID fatigue. And thankfully, more focus on female-specific health questions.
And the gaps. What do we still really need to know?
Key gaps. Definitely more long-term studies in just regular, healthy, non-athletic people. What are the effects over decades for the average person? Crucially, we need more large, well-designed studies in women that properly account for hormonal cycles. That's critical.
Right, to clear up that mixed evidence.
Exactly. And we urgently need more definitive long-term safety and efficacy data in adolescents to help guide policy decisions based on solid evidence, not just precaution. And finally, we're still working out the optimal dosing for all these non-athletic benefits, the brain health, the clinical uses. It seems pretty clear they might need higher doses than the standard 3 to 5 grams for muscle, but nailing down those specific amounts is ongoing work.
Still lots to learn, but the picture is getting clearer and much broader.
Absolutely. The story is far from over.
So we've really come full circle today on Signal 2030. We started with creatine as maybe just that gym supplement, but the science now clearly shows it's, well, remarkably safe, surprisingly effective, and incredibly versatile.
Yeah, the potential impacts really seem to span our whole lives, don't they? From helping brains work better under pressure to possibly supporting healthier aging.
It really makes you think, which leads to a question for you listening. How might this evolving understanding of creatine, maybe supplements in general, shift how you approach your own health and wellness strategy?
Yeah, what stands out to you from our conversation today?
For me, it's just how science keeps refining things, challenging those old myths, opening doors to new possibilities for health. We're really only just beginning to fully appreciate.
Well said.
Thank you so much for joining us on Signal 2030, where we explore these scientific breakthroughs that are shaping our future. Until next time, stay curious.
Hope to see you soon.